Here we have the binomial theorem. What this theorem says is that we have our binomial in the form of p plus q to the power of n, and the solution or the expansion will look like this, like the sum of all the terms from 0 to n being the power of our binomial, of n choose k times p n minus k times q to the k power. And the formula for n choose k is n factorial divided by k factorial multiplied by n minus k factorial. I know it looks a little bit terrifying, but it's not that bad. Let's do some example to see how can we apply this theorem to expand our binomial. So the first example that we have is x plus 1 to the fifth power. How can we apply the theorem to solve or to expand this binomial? Well, it says, hey, you're gonna sum all the terms from 0 to n. So the first thing to identify is what is n for us in our binomial. So n is the power. So n is equal to 5. K is just the number that is going to increase as we go. So the first one will be 0, the second one will be 1 and 2 and 3 until n, okay? So let's start developing or expanding our binomial. It says the first term is n choose k. N for us is 5. Choose, what is the first term for k? We'll start with 0. Then p, which happens to be the first term in our binomial. In our case, p is equal to x and q is equal to 1. So p to the n minus k. So p is x to the n, which is 5, minus k, which is 0. Okay? Then multiply times q to the k power. Q for us is 1 to the k power, which is 0 for this term. And that's the expansion for the first term of our binomial. Then the next term will be, we use plus because we have a plus here. So all our terms are going to be positive. Then we go n choose k, now 5 choose 1, right? Because this term keeps increasing as we go until it reaches n. Okay, so now we have x, 5 minus k, which is 1, then 1 to the power of 1, which is k, right? And that's our second term. Then plus, then 5 choose 2, right? Because we keep increasing 0, 1, 2. Then times x, 5 minus 2, 1 to the power of 2. Then the next term will be 5 choose 3, x, 5 minus 3, 1 to the power of 3. Then the next term will be 5 choose 4, x, 5 minus 4, 1 to the power of 4. And the final term is 5 choose 5, x, 5 minus 5, 1 to the power of 5. Okay, so this is our expansion. But you may notice that, okay, but this is not a number, right? But now we have this equation to solve for each parenthesis or combination. So let's solve 5 choose 0. So we have 5 choose 0. The formula says n factorial. What is n for us? The top number, right? In this case will be 5. 5 factorial. Then k factorial. K will be the bottom number, so 0 factorial. And minus k, so 5 minus 0 factorial. This will be equal to 5 times 4 times 3 times 1 divided by, in the purpose of combination, this 0 factorial is just not taken into account, and then we just have 5 factorial again, it will be 5 times 4 times 3 times 1, and then this is cancel with this one, and we end up with 1. So this number right here is 1. Let's do now 5 choose 1. 5 choose 1 will be 5 factorial, 1 factorial, 4 factorial, right? Because will be 5 minus 1. Then we put this in our calculator and we end up with 5. Now we do 5 choose 2. Somewhere here is 5. Then 5 choose 2 will be equal to 5 factorial, 2 factorial, 3 factorial, which is equal to 10. Now 5 choose 3, 5 factorial, 3 factorial, 5 minus 3, that will be 2 factorial. And that is also 10. Next one, so let's start putting it here. So 10, 10. Next one, we have 5 choose 4. 5 choose 4, this is equal to 5 factorial, 4 factorial, 1 factorial. And this will be equal to 5. Finally, 5 choose 5, 5 factorial, 5 factorial, 0 factorial, that's equal to 1. And that is how we get our coefficient. So if we write down our expansion in a nicer way, it will look like this. Let's delete all this calculation. And now we write down x to the 5th power, and 1 to the 0 power is just 1, plus 5 x to the 4 times 1, plus 10 x to the 3 plus 10 x to the 2 plus 5 x to the 1 power, which is just 1, plus x to the 0, 1 to the 5th power is just 1. And this will be our binomial expansion using the binomial theorem. Okay. Next one will be 2y minus 1 to the 4th power. So let's write down our binomial theorem equation. It says this is equal to 4 choose 0, then the first term, which is 2y, 4 minus 0, and then we have 1 here, 1 right here, to the power of 0. We leave a space empty for the sign. We're going to assign the sign later on because we have a negative sign right here, so we have to be careful. Then we have 4 choose 1, 2y, 4 minus 1, 1 to the power of 1. 4 choose 2, 2y, 4 minus 2, 1 to the power of 2. Then we have 4 choose 3, 2y, 4 minus 3, 1 to the power of 3. And finally, we have 4 choose 4, 2y, 4 minus 4, 1 to the power of 4. Now let's see the sign. We have a minus here, so we start alternating, starting with positive. Positive, negative, positive, negative, and positive. Another way you can do the sign will be, let's delete what we just did, is to include the sign in the term that has it. For example, the sign is in the minus 1, so it will be minus 1 here, minus 1 here, minus 1 here, minus 1 here, and minus 1 here. And then we just start applying it to the entire expansion. Okay, so let's start with the coefficient section. We have 4 choose 0, 4 factorial, 0 factorial, 4 factorial, this is equal to 1. 4 choose 1, that will be 4 factorial, 1 factorial, 3 factorial, this is equal to 4. Then we have 4 choose 2 is equal to 4 factorial, 2 factorial, 4 minus 2 is 2 factorial, this is equal to 6. Then we have 4 choose 3, this will be 4 factorial, 3 factorial, 4 minus 3 will be 1 factorial, and this will be equal to 4. And finally, we have 4 choose 4, and this will be 4 factorial, 0 factorial, equal to 1. Okay, so now that we have all our coefficients, we have 1, we have 4, 6, 4, and 1. Now let's write down our binomial expansion in a nicer way. Let's delete our calculations. And now we write 2y to the power of 4 times minus 1 to the power of 0 is just 1. Okay, so here, this is the term that is defining my sign. Okay, so minus 1 to the power of 1 is just minus. Then we have 4. Then we have 2y to the power of 3. Then this is the factor defining our sign. Minus 1 squared is just positive 1. Then we have positive. Do you see that we start alternating? Okay, so then we have 6 2y squared. And then we have minus 4 2y to the 1 power. And plus 1, which is just 1, 2y to the 0 power, which is 1. And then we have minus 1 to the power of 4. This is 1 positive. Okay, so now we have 2 to the power of 4. This will be 16y to the 4th minus 2 cubes. That will be 8 times 4. That will be 32y cubed plus 2 squared is 4 times 6 is 24y squared. Then we have 4 times 2 is 8y plus 1. And this is our binomial expansion using the binomial theorem. Let's look at some tips on how we can expand binomials using the binomial theorem. The first thing you need to pay attention is to identify the elements in the equation. And where do you have to identify it? You have to identify it in your binomial. So, I mean, n, what is n, what is p, what is q, what is k. Remember that those are the terms in the binomial expansion equation. Then after this, after you have identified all these elements, work term by term. Okay, otherwise you will get super confused and you will not know how to solve it, or if you made a mistake, it will be super difficult to identify where the mistake is. And finally, when you have a negative sign, alternate the sign, starting with plus. This only apply when you have a minus in your binomial. Okay, So these are a few tips that you can apply to use the binomial theorem and to expand your binomial.